Hello and welcome to Morehouse's Math Menagerie, where outliers are always welcome. Today we're going to be talking about chi-square goodness of fit tests. Note that this test compares an observed distribution with the expected distribution for a population. Before we start, here's a fun quote from Ron Swanson. According to the M&M company, I believe it's Mars Incorporated, the percentage of each color of M&Ms is given below. 24% should be blue, 13% brown, 16% green, 20% orange, 13% red, and 14% yellow. I took a sample of 2,620 M&Ms. If the counts reported by the company are true, here is how many M&Ms of each color I would expect to get. And here are how many I actually observed. Note that I expected 628.8 blue, but I only found 568. For the browns, I expected 340.6, and I found 371 in my sample. For the greens, which is the best flavor of all of them, are the 419.2 is what I would have expected, but I found more than that. I found 456. And the expected and observed for orange, red, and yellow are given as well. Now to run my test to see if my observed distribution of M&M colors is a good fit for the expected count of each color, I'm going to first set up my hypotheses. You will note that for all chi-squared tests, there is no parameter to define. This is a little bit different than previous tests. Here, we're just going to have a null and alternative hypothesis. The null hypothesis is going to be that the company's claimed distribution of M&M colors is correct. The alternative hypothesis will be that the company's claimed distribution of M&M colors is incorrect. We are then going to state our procedure and check our conditions. The chi-square goodness of fit test is our procedure. The bag of M&Ms that were opened will be considered a random sample. The 10% condition is met because even though 2,620 M&Ms is a lot, there's way more than that in the world. The large counts condition is met because all the expected counts are at least 5, and you'll note that I've listed out the expected counts when checking this condition. For the calculations, we're going to have a chi-squared test statistic for this problem. We're going to take each observed value and subtract the expected value, square it to make it positive, and then divide by the expected value to scale our data. We will then add up all of these observed minus expected squared divided by expected for each color of M&Ms. Here is the table again of our expected and observed counts with the contributions for each color listed down here below. For each color, I did the observed minus expected squared divided by the expected. If we add these all up, we get 14.898. Now let's jump over to Desmos to take this test statistic and turn it into a p-value. In Desmos, I'm going to open up my inference menu and I'm going to find my chi-squared probability distribution. Now it asks for a degrees of freedom. The degrees of freedom for a chi-squared distribution is k minus 1, where k represents the different values the variable can take on. Since there are 6 different colors of M&Ms, our k for this situation is 6, so 6 minus 1 would be 5. I'm then going to hit Create Distribution. Now, chi-squared tests are always right-tailed. So I'm going to select the right tail, and I'm going to put in the test statistic of 14.898. You can see kind of down here in the red, there's a little bit of an area showing, and we're getting a p-value of 0.011. Now, what if we wanted to run the entire test in Desmos instead of finding the test statistic by hand first? Well, we would go to our inference menu and select chi-square goodness of fit test. Now it's asking us to put in our observed and expected values. I'm going to go ahead and do that right now, and I'll skip this portion so you don't have to watch. All right, now that my values for the observed and the expected are in the goodness of fit columns here, I can go ahead and hit Create Test. Note that there's two different drop-down menus. The first one will allow us to look at the expected and observed values for each of the colors of M&Ms. I can hit this check mark and it'll show those contributions that we calculated by hand before. And it will also give me the total, which is our test statistic down below. If I shrink that and open up our significance test drop-down menu, you can see that it gives us that chi-squared test statistic of 14.9, the p-value of 0.011, and it shows our degrees of freedom of 5. The last step is to write out our conclusion. Our p-value of 0.011 is less than alpha of 0.05. Thus, we reject the null hypothesis in favor of the alternative hypothesis. There is sufficient evidence to suggest that the company's claimed distribution of M&M colors is incorrect. Here's a fun little comic just for a break. Now, when we reject the null hypothesis on a goodness of fit test, it's common that we want to look back and say, okay, well, if the two distributions are different, the expected and the observed distributions are different, where were they different the most? So we want to do something called a follow-up analysis. To do this, we're going to jump back into Desmos. To do the follow-up analysis, we're going to look at these contributions. You'll notice that the contributions are an indication of how far apart the observed and the expected values were. For values that were very close, like this last color here, we observed 369 M&Ms of that color, and we expected 366.8. We got a very low contribution out of that color. However, for our first color, there was quite a bit of difference in between what we expected and what we observed, and we got a contribution of 5.879. That is roughly a third of the total chi-square test statistic. So after looking at the contributions, we would say that we believe the first color, which was blue, was significantly different than the expected, where the rest were less so. Thank you for watching this video. I'll leave you with this quote by Michael Scott. Have a great day.